Now welcome to our new lesson. We will start today with chapter 11, lesson 9, which is talking about normal distribution. We talked about binomial. Today we will talk about normal distribution. Now, we have two types of probability distribution, discrete and continuous. Discrete, I'm talking about a possible events. Now, for the discrete probability distribution, discrete, what does it mean? That means like when I talk about a blood type as an example. That's A minus, or positive A, negative A, positive B, negative B, positive AB, negative AB. So they are discrete. They can be drawn like this. So for this type of probability, we call it discrete probability distribution. Now, the binomial distribution is just here to study the types of discrete probability. So the discrete probability is for binomial, and the normal distribution is for continuous probability. Here you are dealing with interval. Like, I will not ask you at exactly 3 or at 3 from, or I told you probability of at least 2. You will tell me of probability of 2 plus probability of 3 plus probability of 4. So you deal with discrete number, 2, 3, 4. But in continuous probability distribution or in normal distribution here, you deal with the interval. So when I told you now in the normal distribution like this here, when I told you now less than 50% as an example, you will find the area of the curve that is under, or the area under the curve for less than 50. You will not find the probability of discrete. You will find the probability of interval. Is it clear?
Yeah. Yeah.
Okay. So, as I told you, when I told you about the uses of mean and the standard deviation, and that's when we have a mean, we have a standard deviation that is deviated from the mean. 1 standard deviation, 2 standard deviation, and 3 standard deviation. No. So when they draw it now, they know it as a normal curve. This normal curve, we called it a bell shape. Now, as you see here, now they put a standard numbers. The standard numbers, that's for all of the normal shapes. That's for all of the continuous discrete numbers. That is the mean. Now, 1 standard deviation from the mean, 2 standard deviation that's deviate from the mean, 3 standard deviation that's deviate from the mean, and also here 1, 2, and 3. Now, after they draw it, they put an fixed number for the probability. They told me that 34%, that is deviate 1 standard deviation from the right and 1 standard deviation from the left. So when you add 34 plus 34, you find that it is 68%. So 68% of data fall within 1 standard deviation of the mean. And so if you look, they found that the area under the curve from 1 or minus, you can say negative 1 standard, and to 1 standard deviation, the area under this curve is 34 plus 34, which is 68. Now, let's find now the probability of a data that is fall within 2 standard deviation. Within 2 standard deviation, as I told you, here we have the mean. So I'm talking about this area. Let's find now the area under the curve. 13.5 plus 13.5 plus 34 plus 34. So they found that 95% of data fall within 2 standard deviation. And then they want to find now the percent of data that's fall within 3 standard deviation. Which is here, as you see, 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35. They give you 99.7% of data fall within 3 standard deviations from the mean. Now, I want you know also to know that the area, as you see, it didn't close, it's open. It didn't intercept with the x-axis. So, what does it mean? As I told you here, from 3, or you can say within 3 standard deviation, 3 from the left and 3 from the right, we found that the standard deviation here is 99.7. So it's not 100. So what does it mean? That means there's a 0.3% that are halved here. I mean that's where we have a 1.5% here and here. So the first thing I want you to know that the area under the curve is 1. Okay, here, or we can say 100%. Here we have 99.7 minus 100, we have 0.3. This 0.3 is deviated in this green areas here, that's I drew it, 1.5 and 1.5. But because I focused on 3 standard deviation to the right and 3 standard deviation to the left, we have here this 1.5% to the left and to the right. The second thing, that when you have it, the area under 50% here is I mean that when you have the mean here, the area under the mean is 50%. Don't add 34 plus 13.5 plus 2.35. From under the mean here, it is 0.5 or 50%. And above the mean, it's also 50%. So the area under the curve is 1. The area under the curve in half of the mean is 50, and above the mean is 50. And if this state here, if we talk about symmetric bell shape, 50 above the mean and 50 under the mean. Now, some of the bell shapes are not normally distributed. They are positively skewed to the right, to the left, and negatively skewed to the right. Why this happen? Like sometimes there's a factors affect the data. Like as an example, as I told you that all the data are not have the same condition. Like a coin, it's weighted unevenly. It's weighted more than the other coins. So the heads tends to come up more frequently than the tails. So in this case, then the data will not normally distributed, will be skewed to the negative, to the right or to the left. But this is not, yes.
They're associated with the mean. So like they say in the normal distributed, the mean and the median are the same. and then with the negative scores, they say that the mean is more than the median. And then in the positive code, they say that the mean is more than the median. Is that so? I remember something like that.
Yeah. Here, but it is not important for you. Here, when the positively skewed, wait, let me remember first. If there's here a mean, I think that the mean is less than the median in the positively skewed, and in the negatively skewed, the mean is greater than the median. But this is not important for you. Just here to give you that. We don't talk about as you know, we are not living in a perfect life, an ideal life. So not everything are normally distributed. Some of them are positively, some of them are negatively skewed, but this is not so important for you. We just to focus only about normally distributed. We have to not focus on, sorry, the normally distributed. So now let's come back here. For this bell shape, is it clear now? You must know these numbers. You must memorize it. You must know that the area under the curve is 1. The area above the mean is 0.5. And the area is greater than the mean is 0.5. Is it clear?
Yeah, teacher.
Yes.
Thank you.
Okay. Let's start now with the first example here.
Teacher?
Yes, Rose.
The negative, this standard deviation, if the number was not before the mean, like the result number was not before the mean, so it should be correct, it should be incorrect.
The negative.
If,
How?
yeah, if the number, like if I did it and the number of this negative standard deviation was after the mean, not before the mean, it should be incorrect.
The negative standard deviation?
Yeah.
Did you mean
If
in
I
it is
make
here?
like sometime a number which is x bar minus sigma, and the result was after the mean, not before the mean. So what should I do?
There's something wrong.
Something wrong, right?
Yes.
Okay. Thank you, teacher.
You're right. Now, let's come back here to problem number 1. Analyzing normally distributed data. Now, here in normally distributed, the mean, we not call it as x bar. The mean, we call it as mu. Okay? And sigma is an standard deviation. Mu, this is a mean, and sigma is a standard deviation. So mu minus sigma, mu minus 2 sigma, mu minus 3 sigma, and so on. Now,
Teacher, it is mu.
Mu. Yeah.
Okay.
Now, the bar graph gives the weight of population of female brown bears. Now here, before I start here, then the build shape are drawn. In this problem here, it's drawn. Later on, we want to draw it. Let's now analyze it. Here, as you see, we have the weights of population of female brown bears. The red curve shows how the weights are normally distributed about the mean. 115. So the mu here, or the mean, is 115. Here is the mean. Approximately, what percent of female brown bears weigh between 100 and 129? Now, as you see here, I will not tell you what is the probability of weight at 100. And I told you at 100 or at least 100. Deal now with discrete numbers. But here, as I told you, we deal with interval, with a continuous types of data. So when I told you now between 100 and 129, that means you have to add this number plus this number plus this number. Now, between 100 and 129, they are distributed as 100, 109, 110, 119, and 120, 129. Now, from 100 to 109, look at this number here. We can read it approximately as 23. Plus, from 110 to 119, it is 42, we can say, or 41. And from 120 to 129, it's also 23. When you add them now, you will find that 80% of the female brown bears weigh between 100 and 129. Is it clear?
Yeah.
Yes.
Yes.
Okay. Now, approximately what percent of female brown bears in problem 1 weigh less than 120? Now, I want to find the percent of female brown bears that is weigh less than 120. So let's come back here. No, where is 120? It is here. I want now less than 120. So, what I have to say? 41 plus 23 plus 5. Is it right?
Yeah.
Did you give us again from where these numbers 21 and this?
From here. The percent of bears they are given.
Yeah, okay.
Okay, so here it's 41. Here it is 23. And here it is 5. So when you add them, 5 plus 23 plus 41. So let's write them here now. 5 plus 23 plus 41. 28 plus 41. We have it as is there something? Here, if you look at between 80 and 89, we have a number, is it right? We have a blue dash. Here, I mean. Here and here. There's something. It's not exactly 0.
25.
Yes, you can say it's 1.
Yeah, 1. Yeah, 1.
Yeah,
Probably.
1. It's not 0. So we can say 1 plus 5 plus 23 plus 40. 42 we say no. So okay, 5 plus 23 is 28 plus 1 29. 29 plus 42 7 11 71. Yeah. So here we have 5 plus 23 plus 42 plus 1, which is 71%. This is the, I'm sorry, I clear everything. So the probability now of less than 120 is 1 plus 5 plus 23 plus 42, which is 71%. This is the percent of the, what is the question here? Of the brown female, brown bears that is under 120. So here you just want to add the percent that is under the curve, between the interval that I'm asking about you. Now, I'm asking you about it, sorry. Now B, this is for A. Now for B, the standard deviation here is 10 kilogram. Look, come back here. So we have so here we say that the mu is 115, and here we have 10 standard deviation. So 115 minus 10, so at 0.15 here, we have 1 standard deviation, and at 115 plus 10 at 125, this is within 1 standard deviation. Within 2 standard deviation, that's in 115 plus 30, so at 145. So it is here. Plus, sorry, plus, I'm sorry, it's 20. 115 plus 125. Here we have 2 standard deviation. 20 plus 115, which is 135. And here at 95. This is within 2 standard deviation. Now the question here is, so they give me the standard deviation, they give me the mean or the mu. They told me now approximately what percent of female brown bears have weights that are within 1.5 standard deviation. Within 1.5. Now, I told you that the mean, the mu here is 115 and sigma is 10. So 1.5 of standard deviation, that's mean you have to multiply 10 times 1.5, which is 15. So you have to go or to see at 115 plus 15, which is at 120, and at 115 minus 15, which is at 100. So I want now to see the area under the curve between 100 and 120. That is deviate 1.5 standard deviation from the mean. So let's come back here. Let's see, from 100 to 120. To 120, so no. I told
But
you
this is
here.
150.
115, yeah, to 115 plus 15, 130.
Yeah.
Oh, so here 130. So it's up to here. So I want now a percent of female brown bears that is deviate with 1.5 standard deviation. When I told you now that is deviate 1.5 standard deviation, that's mean you have to go 1.5 to the right and 1.5 to the left. 1.5 standard deviation. The standard deviation is 10. So 1.5 times 10 is 15. So since the mu here is at point 115, so you have to go, or you have to add 15 to the 115. So you are at this point here is because you add 115 plus 15, and this point here because you subtract 115 minus 15. So you find they are talking about 100 and 130. So what is the area under the curve here? It's a 23 plus what?
Plus 23.
Plus 42 plus 23. Yeah. When you add them, we have them as 88. So B here is 88%.
So teacher, they said here the standard deviation is 10 and the mean is 115. And then they say like approximately what percent of female, and then they say that if we have 1.5 standard deviation, then how it will be?
Yeah, then add deviate 1.5 standard deviation. Where it will be? You tell me 1.5 standard deviation, يعني you mean 15. 15 to the left, 15 to the right. Okay, where's 15 to the left? You look at your build shape. 15 to the left, that's mean at 100. 15 to the
But
right,
teacher,
that's mean at 130.
why you make it 15 at 1.5?
No, I told you 1.5 standard deviation. Yeah, I told you the standard deviation is 10. So one standard deviation, 10. Two standard deviation, 20. You multiply 2 by 10. Three standard deviation, 30. The 1.5 standard deviation, you multiply 1.5 by 10. You get 15.
Oh, okay. Thank you, teacher.
So يعني 1.5 standard deviation, that means you have to multiply 1.5 by 10.
Yeah, okay. Thank you, teacher.
Yeah. Now, let's have this example here. The heights of men in a survey are normally distributed about the mean. They measure, or they make a survey to know about or to find the height, of men for the men between 25 and 34. They found that 64, you can say like 2, let's say that here we have 2, 4, 6, 8, and 10. Yeah. So 1% of men's between between 25 and 34 are 64 inches, and 3% of men between 25 and 34 is 66 inches. And as you see here now, at 67 inches we have, can say, 5, and at 68 we have 11. At 70 we have, so we have here, they measure them from 64 up to 76 inches. Now the first one, what about what percent of men aged between 25 and 34 are between 69 and 71 inch tall? Where is 69? It is here. Where is 71? It is here. So now here, as you see, we have a normally distributed between the percent of men between 69 and 71. What you have to add? Yalla, tell me. Here we have 12, 14, 16, and 18.
12 plus 12 plus
13.
11, which is 16.
Here we have 13
Plus 16.
plus approximately 16. Okay, this 15.5, I think, and 14,
And
14.
14.5.
14.5, yeah.
So when you add them here, 29, no, 9 plus 1, 13, 20. So we have as a 43.5% of them between 69 and 71. Now, are less than 70.
So all of the numbers less than 70.
Yeah, so they are
1 plus 3.
1,
I think it's going to be 8 because like no, it's not 8.
1
plus 3
plus 3
plus 5
plus, we have say 4, 6 plus 5, yes.
And 5.75.
plus
And 5.75, okay, or 5.5.
And then
And then
11.75.
Yeah.
Yeah. And
And
then
13.
13.
And then
Teacher, these kinds of questions, they will not be the exactly same. They will vary, right? The answer of them.
yeah,
Like if
here